This is my favorite expression. Oh, maybe that's the YouTube thumbnail. You won't believe it! Whatever. An expression in math terms is a kind of like a math sentence fragment, meaning there's no equal sign. This would be an expression. It's just some math things. There's more definitions that will classify what's going on here a little bit better. So let's do that. We have something called a term. A term in math is things that are separated by additions and subtractions. So in this expression here, 4x squared, that's a term. This negative 3x, that's a term. 1 is a term. So let's take a look at 4x squared. 4x squared. So the factors of a term are the things that are like being multiplied together. So 4 is a factor, x is a factor. There's two x's in here technically, like that. The coefficient of a term, whatever constant number, is being multiplied by the variables. I'll reiterate that if you're doing any sort of substitution for variables, you need to use parentheses. So for instance, if we had this expression again and I denoted x was equal to negative 5, then we would have 4, and then I'm replacing the x with negative 5 with parentheses. Any sort of substitution, you use parentheses. Sometimes it's trivial, but it's just a good habit to get into. Minus 3. Again, x is negative 5 plus 1. Then we do order of operations to clean this up. Even though there are parentheses, we've done everything we can inside of them. So we just go straight to exponents, which is just this square here. This 2 is only looking to square what's inside this little parentheses bubble here, because this 4 is connected to the rest of this in this term by multiplication. We are squaring negative 5. Now a negative times a negative is a positive, and then 5 times 5 is 25. So we have positive 25. 4 times 25. Now we'll do the multiplications. Slash divisions. No divisions here. So 5 is 100. Okay, so we have this subtraction, but then we have this 3 times negative 5, which positive times a negative is a negative, and then 3 times 5 is 15. But this subtraction here is different than this negative here. This is one of the easiest things to mess up when you're doing order of operations, is keeping track of your negatives. So what I like to do is kind of use the parentheses here just to make an extra little layer here to make sure I have these two separate. If you don't feel comfortable with creating extra parentheses, feel free to just have this minus a negative here, but really remind yourself that this negative and this negative are two separate negatives. Opposites. Minuses. The reason why I can do both of these multiplications kind of in the same line is because I know that because these are two separate terms, the multiplications on this one are going to not be affected by the multiplications on this one. Because, I did say to do each step on a different line, but knowing that this is holding back any sort of crossover between those two terms, I know it's kind of like a barrier. I know I'm not going to cross over this until I'm ready to do all of them. Then, if you remember, subtracting a negative is the same thing as adding. A positive. If you want to do something like this, oh, not a red. How about green? Like green for go, yeah. Or you can, if you're scared, which it's messing up negatives is the easiest thing to get scared about. So you could just write it on a separate line, so you don't lure yourself into thinking that you're doing an extra step or skipping a step or whatnot. Okay, then we have a very tame addition of, I mean, I can do this if you want, or you could just go straight to 116. It's up to you which steps you want to skip. Some of them are going to be a lot more obvious and a lot harder to mess up.